Alright, Chapter 5. Using pre-built methods. Well, we've already been doing this. The scanner class, for example, we've been using the scanner class for a long time, and when you call .nextInt or nextDouble or something like that, that's a method. And this slide is telling us that the math class also has, methods. We probably have used some of those before. Scanner and math are part of the so-called API library, Application Programming Interface, the stuff provided as part of the Java language installation. So when working on a programming problem, you should routinely check to see if there's a pre-built class that meets your needs. So example, there's a formula you can write that'll calculate the value of pi. But do you want to write a formula to calculate pi if you can use something that the math class gives you? Absolutely not. Do you want to write a program that can calculate the arctangent of a number, or that can open a file? And no, all that stuff is provided for us. So the reason to use a pre-built method, one that's given to us, is it saves the programmer time, and it's been tested over years and years and years. So the programmer can feel pretty comfortable that the classes have been thoroughly tested and that they work properly. It's possible you may find a bug in it that, that 50 million other Java programmers haven't been able to find in the last 15 years. But pretty much you can rely on them to work pretty well. So there is a formula for calculating the square root of a number, but I would rely on the math class's square root method. So Java's pre-built classes are located in its class library, known as the Application Programming Interface. If you want documentation on them, you should be able to visit this website. You also, once you're inside NetBeans, should be able to do View Java Doc, Online Docs, and Support. And hopefully it'll take you to those pages. Oh, it looks like the NetBeans help instead. But when you're inside a project, and you need help over something like the scanner class or the string class, you should be able to highlight it, right-click it, and do Show Java Doc, and it'll show you help for the string class. Now, it seems like last time I did this, I got an error, but I bet it's working on y'all's home setups or your laptops. Oh yeah, just proved me wrong. Fastest way to get help is actually probably to go to Google and do Java string documentation, and it'll pop up a list of them, and it'll just be the top one, right? Java Platform SE7. Well, there seems to be other versions of it, but they're all pretty much going to be the same. And once you get into one of them, then you can do searches for other things. You want to find out how the scanner works? Just do a search for the scanner. I can't say that looked great, that I found what I wanted. Members of the scanner class. Types. All right, and there we go. Right, there's the scanner. Teaches us how to use it. So I think since we're on Lecture M, why don't we make just a little play application, play around with. If you're doing it on your laptop, choose Java Ant. Did those install at home? Mm-hmm. Okay. There seems to be something blocking them here. And I need to ask the IT guys what. So Lecture M. I'm going to remove the package declaration so it doesn't cause me problems later. Everything up to and including the dot. All right. So the math class, what kind of goodies do we have in there? I'm just going to type math dot and take a look. There's a whole bunch of stuff. Add exact. What does that do? Returns the sum of its arguments, throwing an exception if the result overflows. Well, that's useful. If you're adding two numbers too large to be stored into an int, it's worth knowing. ABS stands for absolute value, like the absolute value of -7 is 7. You want to take the exponent of something. No, returns Euler's number, e. So it's not the exponent, it's e to the power of.
Ugh.
Don't want to mess with that. Log and log base 10. Where's log base 2? I guess log is just.
I like the format, how they define each function, and how,
Yeah.
how they show it instead of C++'s.
How to calculate log base 2 of a number in Java. Okay. Math.log x divided by log of 2. All right, that's more mathy than I wanted to get, but if I needed to learn how to take the log base 2 of something, I could do that. Math.log of that number divided by math.log of 2. Might be fun to do. Let's write that method just for fun. Write our own method. Public static double log 2 int x. Or why not make it a double? And we're to calculate our result. Double result equals log, math with capital M dot log parentheses x in parentheses divided by math dot log parentheses 2. And then we need to return that result. Return result, semicolon. So let's just calculate some values. Int a1 equals log 2 parentheses 8. Int a2 equals log 2 parentheses. Oh, these should not be ints. What should these be? What type is the method determined? Yeah, it's declared as double, so these need to be doubles. And log base 2 of 16, semicolon, and double a3 equals log 2 of 32. Let's just print those out. System.out. I accidentally wrote log 3. That was not my intent. System.out.println parentheses quote a1 equals, or a1 equals end quote plus a1. And I'm just going to copy and paste that and make it a2 and a3. Hammer and broom it. Run it. All right. And so the log base 2 of 8 is 3. The log base 16 is 4. Log of base 2 of 32 is 5. Maybe you can see the pattern. These are the powers of. Right? 2 to the power of 3 is 8. 2 to the power of 4 is 16. 2 to the power of 5 is 32. Who cares what the meaning of log does? We've seen how to use a math library. Notice that you did not have to instantiate a math object. When we use scanner, right, scanner, sc equals new scanner, parentheses system.in, when we use that, we had to create a scanner object using the new keyword. But you don't have to create a math object. That'd be really annoying if just because you wanted to, calculate the absolute value of something, you needed to create a new object just to do that. That's because math.log and math.abs and math.square root and all those methods are what are known as class methods, meaning you do not have to create an object of that type. Now that I've typed that, it's going to give me an error until I go and add the correct import for it. So I'm just going to scroll up to the top. I got into trouble last time we did this. You could just click on the error and make it fix it. Import java.util.asterisk, and it'll give me all the methods, all the classes that are defined in it, including the scanner class. So that's worth making a note about. The math methods do not require you to create a math object. You just use the name of the class followed by a dot. Examples: math.square root, math.abs, math.log, math.pow, math.pi, right? All those things. So these are called class methods because they are called using the class name. Scanner's not like that. In order to call nextInt or whatever, we have to use that scanner object we created. You know, some people are calling that std, you know, in, which is fine. Whatever you call that variable. To use the scanner methods, though, you have to create a scanner object. And then use that object's reference variable followed by a dot. Example, scanner sc equals new scanner, etc., etc. And then sc.next line, sc.next int, etc. And so since this is an instance of the scanner class, these are called instance methods. These are called instance methods because to use them, you have to have an instance of the class. You have to have an object. Whenever you hear the word instance, think object. Whenever you hear the word object, think instance. They're the same thing. A house is an instance of a blueprint. A car is an instance of the specifications for the car. This SC here is holding a reference to an instance of the scanner class. You know, a pencil is an instance of something made by the pencil factory. So let's ask the user for a number, and then let's do things with it. Don't know what, but let's ask them for a number. System.out.print parentheses quote. Please enter a number, colon, space end quote, parentheses semicolon. Now let's declare our number, double D, D equals sc.next, capital D double, parentheses in parentheses, and let's do things with it. Like D equals math.sqrt, parentheses D. Or maybe we should declare new variables, right? So double D1 equals math.sqrt D. Double D2 equals math. I don't know. POW, 2 to the power of D, 2 comma D. Double D3 equals math dot absolute value of D. And so on. By the way, if you didn't have a square root function, if you took D to the power of 0.5, it would give you the square root. If you need the cube root, you can raise D to the power of 1/3. So double D4 equals math dot POW D comma 1.0 divided by 3.0. That'll get the cube root. Just a little trick of math is that if you take a fractional power, 1 to the power of 1/2, that's the square root. 1 to the power of 1/4, that's the fourth root. 1 to the power of 1/3, that's the cube root. And we could print these out if we wanted to. system.out.println parentheses quote square root equals end quote plus d1 in parentheses semicolon, and let's just do the rest of them. Print out to the power of. I'm going to copy and paste that print line again because it's so much easier to do it that way. So 2 to the power of d is equal to d2. ABS of d is equal to d3. And cube of d is equal to d4. And I'm going to modify this one to be the square root of d. And I can make this more English-like, right? Absolute value of d. And I can make this more English-like, square root of d. And I can make this one more English-like, 2 to the power of d equals. And I wonder if that actually works, or if I've made some mistakes. Please enter a number. Alrighty. How about 10? The square root of 10 is 3.1. That's odd. That almost looks like pi. Not really, but 2 to the power of 10 is 1024. The absolute value of 10 is 10. The cube root of, I forgot to say cube root. The cube root of d is that. So let's do that. Cube root of d. And one last one. Double d5 is equal to math.POW d comma 3. And we're going to say the cube of d. So I need to copy my print line statement one more time. And then to say cube of d is d5. Cube of d equals d5. Negative 10. Alrighty. Notice that the cube root of negative 10 is not a number. Huh. Guess I'll buy that. The square root of negative 10 is not a number. Well, it's an imaginary number, I being the square root of negative 1, but I guess I can't blame it for not being able to calculate it. Surprised I couldn't get the cube root, though, because it really does have a cube root. If I went to Google and did 10 to the power of 1 over 3, it'd actually give me an answer. No, negative 10. Right, but the Java library is not returning a valid value. It just doesn't want to take square roots or cube roots of negative numbers. Well, let's pause there. Make sure everybody's caught up. While we're thinking about it, I want you to the volume of a cylinder is this equation. I want you to use math functions to calculate V. Ask the user for R and H and calculate V. So you're going to use math.pi for that, and I'd like for you to use math.pow for that. So this is a little lab experiment while I'm wandering around helping people. If you're already done, then write a program that asks for R and H and calculates V using math.pow and math.pi. Alright, suddenly taking a hard veer for the left. If you have a string like this, and you want to get the first letter out of it, that's pretty easy. char s1 equals s dot char at parentheses 0. The last one's a little bit tricky because that's position 0, 1, 2, 3, 4. But we don't want to just hard code 4 there. And in Java, you could put -1 and it would magically figure it out, but this won't. So we need to get the length of the string. Int len is equal to s dot length, parentheses in parentheses semicolon, and then we can say char s2 equals s dot char at length -1 in parentheses. Because this thing is 5 characters long, and the length of it is 5, and so that's position 4. That's one of the homework questions, isn't it?
Yes.
Yeah.
Okay.
For every input, no. For every program, yeah, but once you create it, that's enough.
Okay.
So I'm going to use it again to try to solve this problem that I asked, where I asked for the radius and the height and calculate the volume. So I need several variables to hold all this stuff. Double r comma h comma v semicolon. Now let's ask for the radius and ask for the height, and let's tell them what we're doing. System.out.print ln parentheses quote. Let's calculate, or get, how about that? Get the volume of a cylinder. End quote in parentheses semicolon. And we're going to ask them for the radius and the height. So we have two questions. System.out.print parentheses quote. What is the height? Question mark space. End quote in parentheses semicolon. So what do I need to do now to read it in? What's my next statement going to be?
Let's
Height, h
Right,
equals
right.
SC
Height is equal to my scanner, sc.next double. Exactly. And I'm just going to copy and paste that to make it radius. That's how I get ahead of y'all, because I'm way more dedicated to copying and pasting than y'all are. And now we can calculate the volume according to that equation.
Okay, so you define it as a scanner every time.
No, you only need to define the scanner once in the program.
Well, I saw the SE next double. That's why I.
Yeah, but I'm just reusing a scanner that I already had defined up higher.
Oh, okay, yes.
Yep.
So you're attaching the old scanner to the variable, and so that's.
So V is equal to, how am I going to get pi? Capital M math dot pi times, and I want to take r to the power of r, so I could just do r times r, but I want to be all mathy. Math dot POW r to the power of 2 in parentheses times the height. And then I could print it out. System.out.println parentheses quote. The volume of that cylinder is space end quote plus V. Now the answer may have a bunch of decimal points, and we might want to just, round it down to 1 or 2 decimal points. There's probably a math.round function that would help us out if we cared. Or we could use printf to limit the number of, decimal places it prints. So please enter a number. Okay, this is going to get tedious. -1. Volume of a cylinder. What is its height? 10. What's its radius? 10. And the volume of it's 3,000. I guess I believe that, because 10 squared is 100 times 10 is 1,000 times pi. Yeah, I believe that.
bugging me all day.
Yeah. So, this is the package. And so we add the import. We could just do import java.util.asterisk to bring in all the classes. This is the class inside the package java.util. So a package is a group of classes. And whenever NetBeans is trying to add the package statement, it's trying to get us to group all of our classes into a package, but we don't have to. So some classes are so important that the compiler automatically includes them. We don't have to import them. Those are called Java. Those are part of the java.lang package. Let's take a look. I'm going to type in java.lang dot and just see what pops up in my editor. I don't know why I'm staring at the screen looking for this when I should be able to see it. There we go. So java.util dot, and here's a whole bunch of classes that are already built in, because java.util, wait, no, that's not true. Java.lang, that's what it's telling. Java.lang dot. And here's all the different classes that we have by default. Scanner is not one of them. That's why we have to add an import. Like system and thread. Let's find out what system offers us. System dot. Array copy, console, load library, nanotime, class. Oh, I don't know. I don't know if I want to use any of those. How about java.lang.thread dot sleep parentheses 1000 or 5000. What does sleep do? Well, since java.lang is already included, I don't need to type all that. I can just do this. Thread.sleep. Why are you giving me a complaint there? Unreported exception. Okay, I don't want to get into exception handling, so I'm not going to talk about this. But what this would do, if we'd been able to add it without adding some extra stuff, is what a sleep is it just pauses the program for 5 seconds. It so-called puts it to sleep so that it's not doing anything. So there's a whole bunch of classes built in to Java. A lot of them are inside java.lang, imported automatically. The math class is one of those. So API headings. To use an API, you don't have to know the internals. We don't know how Scanner is written. We just need to know the interface. The interface shows you the name of the function, the parameters you have to pass in, and then what it returns. So public int nextint. When we call nextint, we don't have to pass in any arguments. So the header doesn't show anything between the parentheses. The return type of nextint is type int, because when you call nextint, it returns an int. And it's public, so we can access it. And so when we want to call it, int days equals stdin.nextint. So source code headings for API methods are usually called the API headings. The math class, the ABS file, takes an integer and returns the absolute value for it. But there's also a version of it that takes a double and returns the absolute value of that double. And then there's one called max, which takes two numbers and returns the larger of those two ints. There's another one called max that takes those two numbers and returns the larger of the two ints. And go on. Min takes the smaller of those two ints or those two doubles. POW takes a number and raises it to a power. Random is kind of nice, but there are better classes for it. It returns a random number between 0 and 1, not including 1. Let's play with that. Let's print out some random numbers. Double R1, R2, comma R3. R1 equals math.random parentheses in parentheses. R2 equals math.random parentheses in parentheses. R3 equals math.random. And that should have been an M there, not an N. So now I'm going to run it. And if you take a look, oh, I have to answer those annoying questions. This is when I begin to regret asking for input in our test programs because we have to answer them every time. Enter number 1, height, radius of 1. I forgot to print those numbers out. Brilliant. Okay, so system.out.println parentheses quote R1 equals end quote plus R1 in parentheses semicolon, and do some copy and pasting. R2 and R3. All right, and there's my random numbers. That particular method generates numbers between 0 and 1, except not including 1. 0 is inclusive, 1 is not. Now, what if we were going to write a die rolling program, right? Well, we'd have to convert those random numbers somehow to a number between 1 and 6. And it would look kind of annoying. What do I mean by that? Well, say we took that number. So int D1 for our first die is equal to R1 times 1,000,000 modulus 6 plus 1. And that turns it into a number between 1 and 6. Except I'm getting an error, because I'm going to have to take this value and turn it into an int. So this needs to be int parentheses. Well, that's not going to work either. That's not Java. That's C. Okay, we're going to do it in 2 steps. See, this is why it's annoying to use this particular method. Int D1 equals R1, or parentheses, int in parentheses, R1 times 1,000,000. 1, 2, 3, 4, 5, 6, semicolon, and then put that expression inside parentheses, like that. R int, close parentheses, open parentheses, R1 times that. Oh, stop it. Variable D1 is already defined. I guess it is. Okay, fine. Dice 1 equals int. All right, and then we can do modulus 6 plus 1. That will make our number a random number. Convert it to a number between 1 and 6. Now that's kind of annoying, but it works. So let's print it out, and let's do the same thing to the other 2. So I'm going to copy that statement and change dice 1 and R1 to dice 2 and R2 and dice 3 to R3. And I'm going to print those out. I'm just going to copy this entire block of print statements and change all the R's to dice. Right click, copy, paste. Dice 1 equals plus dice 1. Dice 2 equals plus dice 2. And dice 3 plus equals dice 3. Now, I don't like the fact that those numbers are in sequence. That looks suspicious, so I'm going to run it again. No, wait. Keep forgetting I have to enter all this input before I get to my output. There we get 5, 4, and 6. The next time I run it, I should get a different sequence of numbers. Two, 4, and 1. Okay, so you know what a die is. It's a cube that's got 6 sides. If you wanted to generate a different random number, like a number between 1 and 100, you would just change that 6 to 100. If you wanted it to start at something other than 1, you'd modify it so that, you know, you added something else to it. If we had the random class, it'd be a little bit easier. Here's what the random class looks like. Random R1 equals new random with capital R's. Except I'm not going to be able to call it R1. I've already got a variable of that type, so I'm just going to call it random R&D is equal to new random. And if you get, as I suspect Parker will, a red box over here, a red message, just click on it and say add import. I didn't have to because import java.util.stars already got me covered, but yours says import java.util.scanner. Now I'm going to get those random numbers again. Dice1 equals R&D dot next int parentheses 6 in parentheses plus 1 semicolon. Because it's going to give us a number between 0 and 5. I believe that to be the case. We'd better look at the documentation for that and make sure that's true. In Java, it's inclusive. It'll go up to that number. In Python, is it inclusive? Let's find out. Java random next int. Google that up. N is the bound on the random number. Must be positive. 0 is inclusive and n is exclusive. So if you want to generate a number between 1 and 6, you add 1 to it. Otherwise, you'll get a number between 0 and 5. And we could print these numbers out again. Maybe you agree with me that this looks better than this did for generating the random numbers, right? I mean, not that this is impossible, but if I don't have to multiply it by a million and convert it into an int and then modulus it, I'd rather not. So you can use math.random to generate a number between 0 and 1, or you can use the math class to generate a number up to any specified value. That's not the math class, sorry, the random class. That's what we did in our second example. If you don't want to have to do import random and import scanner and everything separately, you can change your import statement to just java.util.asterisk. And then you get the scanner class and you get the random class.
So that's just the main util. That's
Yep.
Oh, I wish C++ had that, so we don't have to do it boilerplate every time. I like that.
Yeah, because we have like 6 different # includes or in our boilerplate so far. And then there are wrapper classes. This is like Dr. Dre and Jay-Z and Ludacris. No, I'm kidding. What wrapper classes are is in this language and in C#, the value, excuse me, in C++, the values, the variables like int and long and double are what are known as primitive values. We can't use you can't use your x dot, you know, and then get some extra methods, some extra functions out of them. Like here I have, you know, an int called dice1, but I can't do dice1 dot and get extra powers, right? I can't convert it to a string or do anything like that. But if it was an integer with a capital I, if it was part of the integer wrapper class, integer I1 equals dice1, semicolon, now I can do things to it. I1 dot. I could get the floating point value of it. I could compare it to another integer. I could get the byte values out of it. I could convert it to a string. So string s1 equals I1 dot to string parentheses, and you know, I could do something with it. What is the maximum value of an integer? Well, let's find out. Let's do int space imax equals capital I integer dot max underscore value, semicolon. And then int I min equals integer dot min underscore value. And we'll see that the maximum value of an integer is about 2 billion and the minimum value of an integer is about negative 2 billion. And I forgot to print them out. System.out.println imax equals end quote plus imax. Do the same thing for imin. So these are called wrapper classes because you can store your integer into a variable of this type and do extra things with it, like convert it to a string like that, or parse it. There's a parse function that will convert a string into an integer. And what if we did this? S1 equals, quote, 999, end quote, semicolon, and you wanted to turn that into an integer. Int I equals capital I N T E R, capital I, integer, dot, parse, capital INT, parentheses, S1, in parentheses, semicolon. And now we have turned that number into an integer. I said number, it's not a number, it's a string. You can't do math on a string, right? It's just like typewriter characters, whatever the user typed in. Now we're lucky enough that the scanner class gives us a next int and a next double and things like that. But we could be using a language, or we could be in a circumstance where we only get strings and we have to convert them to ints. Java is like that. Java gives you strings, and so you use the int or the float function every time you want to do math on it. Well, we don't normally have to do this at this stage in the game because we have next int. So double D value equals capital D double dot parse double with a capital D string S1. And so on. If you wanted to convert it to something else, you know, you could use the wrapper class for that. I haven't run it yet to actually see what the max and the minimum values are, so I'm curious. I'm going to go ahead and run it. So the maximum value is a little more than 2 billion. The minimum value is a little less than negative 2 billion, right? So if a number is going to be larger than that or smaller than that, you better store it in a long. Well, what's the maximum value of a long? Let's find out. System.out.println parentheses quote max long equals end quote plus, I'm going to use a capital L long because I'm referencing the wrapper class now, capital L ONG dot max underscore value. in parentheses semicolon, and as usual I'm going to copy and paste that and change it to min. Min, the minimum value of a long. And we're going to see that it's much, much larger. Longs can hold much larger values than integers because they are 8-byte values rather than 4-byte values. Got a lot more bits to play with. There we go. There's the maximum of an int and the minimum, and there's the maximum of a long and the minimum. Much larger. So if you need a number larger than 2 billion, you're going to store it in a long. And we'd already talked about that before. We could also calculate and print out the maximum double, right, if we cared. Why not? Just paste this one more time and make it say max double equals, and change that to double dot max value. So max double is equal to capital D double dot max value. And it's a huge number, right? It can support something with up to 308 zeros after it, e to the 308. So doubles hold very large numbers, but they have less precision, right? They have like 16 places of precision, which is a lot of precision. I mean, there's not many more than that, but integer math is exact, right? You add 2 integers, you know that the answer is going to be exact. But floating point math, we've talked about this before. As you add floating point numbers together, you get rounding errors. That is about far enough into the lecture, I think. So here's what your homework is going to be. Use Google to find the formula for the surface area and volume of a sphere. Write code that calculates that that gets a random value between 1 and 1,000 and uses that as the radius to determine the surface area and volume of a sphere. Probably a short program. Might only take you 5 minutes. If it takes you longer, that's fine. If you get stuck looking for the formulas, you can always text me and I'll point you to them. That makes sense, gang? Just going to tie together the idea of random numbers. You can use either the random class or use math.random and do this permutation on it, right? But if it's going to be between 1 and 1,000, then you would just add, modulus it by 1,000. Or use dot next, wherever that was, right? Next int and put 1,000 there rather than a 6. All right. Any questions? Yes, ma'am. Okay, click on that, and it says cannot find random. Click on it, and just like we do a scanner, do add import. Yeah, and that'll make it go away. And it's interesting that we're getting warnings. Let's go and look at one of those warnings. Oh, did they go away? I thought I saw some warnings popping up, but now I don't see them. Oh, there they are. What does that say? Assigned value never used. Oh, that's fine. I mean, we could print them out if we wanted to, but